Hi, welcome to myprojectbazaar.com.
Now we are going to study about honeybee behavior inspired load balancing of tasks in cloud computing environments. Introduction. In our basic domain is cloud computing. Cloud computing is an entirely internet based approach where all the applications and files are hosted on a cloud which consists of thousands of computers interlinked together in a complex manner. Cloud computing incorporates concepts of parallel and distributed computing to provide shared resources, hardware, software, and information to computers or other devices on demand. These are emerging distributed systems which follows a pay-as-you-use model. The customer need not buy the software or computation platforms. With internet facility, the customer can use the computation power or software resource by paying money only for the duration he or she has used the resource. This forces the conventional software licensing policies to change and avoids spending of money for the facilities the customer does not use in a software package. Next, we are going to abstract in our project. Load balancing of non-preemptive independent tasks of virtual machine is an important aspect of task loading in cloud tasks. Whenever certain VMs are overloaded and remaining VMs are underloaded with tasks for processing, the load has to be balanced to achieve optimal machine utilization. In this paper, we propose an algorithm named Honeybee Behavior Inspired Load Balancing, which aims to achieve well-balanced load across virtual machines for maximizing the throughput. The proposed algorithm also balances the priorities of tasks and the machines in such a way that the amount of waiting time of the task in the queue is minimal. We have compared the proposed algorithm with existing load balancing and scheduling algorithms. Our approach illustrates that there is a significant improvement in average execution time and reduction in waiting time of tasks of queue. The specific contribution of this paper include an algorithm for scheduling and load balancing of no preemptive independent tasks in cloud computing environments inspired by honeybee behavior. A literature review about various existing load balancing algorithms and merits redeems these techniques. Correlation of proposed HBBLB algorithm with actual foraging behavior of honeybees using a clear flow diagram showing a behavior control structure of honeybees and HBBLB. An analysis and a systematic study with mathematical evidence to show how the honeybee behavior inspired load balancing can work for cloud computing environments. Performance analysis of the proposed algorithm and can evaluation of the algorithm with respect to other existing algorithms. Objective of this project: load balancing of non-preemptive independent tasks on virtual machines is an important aspect of task scheduling in clouds. Load balances the priorities of tasks and the machines in such a way that to speed up the execution of applications and resources whose workload varies at runtime in unpredictable way. Data flow diagram. Start your application, then going to cloud configuration, virtual machine allocation, virtual machine capacity, cloud broker, data center, then going to load of virtual machine, task scheduling, then virtual machine grouping. Then we have to load balancing two types. One is the state of the virtual machine group, one is a overloaded virtual machine group. State of virtual machine group is a VM load greater than or equal to threshold condition is system balanced. Going to task transfer. Also overloaded VM group for L greater than maximum capacity means load balancing is not possible, else trigger load balancing. After you have to task transfer, then scout B, then find out the load balanced VM or overloaded VM or balanced VM, then file transfer low loaded VM find option. Stop the process. Let us start a project demo for honeybee behavior inspired load balancing of tasks in cloud computing environments. First you have to create data center. I have one data center created. This is the number of machines. This is host ID 01, number of P's 3, and the RAM 1024 and 1048, bandwidth size to 25,000. Next, broker creation. I have some broker creation. This is broker ID. This is scout ID. Next, Now we have to create a virtual machine. I have 8 virtual machine creation. This is virtual machine ID. This is broker ID. This is MAPS in virtual machine. This is RAM size in virtual machine. This is bandwidth size in our virtual machine. Next, task creation. It means a cloudlet creation. I have 50 task creation. Click cloudlet creation. Now we have created tasks. This is cloudlet ID. This is broker ID. Length of our input task. File size. This is output file size. Click next. Configure our cloud configuration for between tasks and cloudlet. This is cloudlet ID. This is every cloudlet ID has been status success. This is data center ID. This is virtual machine ID. Allocation, task allocation, time allocation. In every virtual machine, every cloudlet task has been allocated time. Next we are going to VM group configuration. Virtual machine ID. This is task ID. This is data center ID. Next, I have to create virtual machine master. We have used architecture of 80 virtual machine is x86 operating system Windows. Virtual machine manager is Zen. Time zone 10.0, cost 3.0, cost per minute 0.05, cost per storage 0.0.1, cost per bandwidth 0.0. This is virtual machine. This is virtual machine ID, bandwidth, RAM size, MAPS, number of Ps, number of virtual machines, load in every virtual machines. Next, scheduling computation. This is virtual machine ID, unique ID 3. This is bandwidth, RAM and MAPS and number of PES. This is load based or brokers and virtual machines. We find out total load in every virtual machines. Next, now we have to load balancing for every virtual machines. You have to find balanced system or imbalanced system. Now we have an imbalanced system. This is broker ID, all VM load, VM ID, bandwidth and all bandwidth, total VM load. Then system deviation values is 1.6568. Now we have a imbalanced system, so we have to find load balancing possible or not. Virtual machine 0 has been load balancing is not possible. Same 57214663. We have to find virtual machine group balanced virtual machine 3 4 5 7 8 9. This is only balanced virtual machines. Then we have to find out underloaded VM and overloaded VM. Values of 0 virtual machine overloaded VM is and low loaded VM is 24998. 0 virtual machine is overloaded VM is minus 24998. Same as all possibles. Then we have to next. First we have to find a task priority. This is our input task, virtual machines. Then honeybee behavior load balancing. Foraging for honeybee. Task 0 task load balancing in 0th virtual machine 3275. First you have to apply 0th task 1024. Total load is 0th virtual machine 34025. We have to use 1267 file size, so value is 32758. same also 0 0 0 0 5 2. Within 4 virtual machine used in our overall tasks. Fighting for in every virtual machine, we have find out the best virtual machine in Honeybee going to performance analysis. First performance is a VM time compression. Second, virtual machine comparison based upon existing system and a proposed system. Thank you for watching this video.